Hello, ladies and gentlemen. We're going to do 5.4b today. We're going to be talking about integrals of exponential functions. Our objectives are really challenging. We're going to integrate exponential functions. And then the one integration rule for exponential functions is the integral of e to the x dx is e to the x plus c. That is, of course, if it's an indefinite integral. If it's a definite integral, then I would need to manage my endpoints. The only thing that I might need to remind you is that we might need to do some u substitution. Again, you are blessed children. You only have 3 examples today, so we might make it under 5 minutes again today. Woohoo! All right, first example. If I have the integral of 5x e to the negative x squared dx, and I want to integrate, the first thing I can do is move that little 5 out front, and then I'm going to have x e to the negative x squared dx. So I'm going to let u equal a negative x squared du is a negative 2x dx. Well, notice I have the x and the dx. The only thing that's missing is the negative 2. So I'm going to introduce a negative 1/2 on the outside, and I'm going to have e to the u du. Well, the integral is just, here's the negative 5/2. It's going to be e to the u plus c. I substitute my u back in, and I'm going to get a negative 5/2 e to the negative x squared plus c. And then I would write my statement at the end. So the integral of f of x dx is going to equal negative 5/2 e to the negative x squared plus c. Remember that when you're doing u substitution, you don't want to leave your u in your final answer. That's pretty easy. For our second example, I have the integral of e to the 1 over x squared dx. So again, I'm probably going to have to do some u substitution. Remember, if you choose something to be u and it doesn't work, you don't panic. You just start over and choose a different u. Well, in this one, I'm going to let u equal 1 over x, and I'm going to write that as x to the negative 1. So then my du is going to be a negative x to the negative 2 dx. Well, notice I have x to the negative 2 dx, so the only thing that's missing is the negative. So I'm going to introduce that on the outside of my integral, and I'm going to have an integral of e to the u du, which is just a negative e to the u plus c. Way easier than it looked. So then if I keep going, I'm going to have a negative e. My u was 1 over x plus c, and then I would write my final answer. So the integral of f of x dx was equal to a negative e to the 1 over x plus c. Whew! 2 down, 1 to go. So the next one is a wee bit more challenging. Sorry about the glare as I change paper. So for your last example, if I have the integral from a negative 1 to 0, it's a definite integral, so I'm not going to have a c, and I have e to the x cosine of e to the x, and then dx. On this one, I'm going to let u equal e to the x. So my du is e to the x dx. So it's interesting that it's on the inside. Here's the e to the x dx, so I don't have to introduce anything. So this is the integral from a negative 1 to 0, cosine of u du. Well, that's pretty easy because the integral of cosine is a negative sine of u evaluated from a negative 1 to 0. So then I'm going to substitute it back in. This is a negative, and then I have the sine of e to the x evaluated from a negative 1 to 0. So this is going to be a negative sine e to the 0, and minus a minus is plus. And then I have, sorry, I was looking the sine of e to the negative 1. This part is 1, so I'm going to have the negative sine of 1 plus the sine of e to the negative 1 calculator exercise, and I get 0.482. I need to record my final answer, so the integral from -1 to 0, f of x dx, is a 0.482. And that, my dears, is the end of today's lesson. Woohoo! Didn't make it under 5 minutes, but close. All right, guys, I will see you tomorrow.